Okay, so now we are at the extensive challenge questions. So we want to find the area of triangle ABF. So, when you're just looking at it, it's pretty hard for you to find any, like any half area model. But as I said in the lesson, we can just try to seek for a point that is joining three of the vertices of this square. And you can see that A goes to F, B goes to F, C also goes to F, right? So it means that if I am to add an assisting line there, I'm definitely gonna add it at FD, right? Such that now I can find a half model in this question by the opposite triangles. So the first step is to join DF or FD. And now we can see that ABF, the area of triangle ABF, is equal to the area of triangle, the area of triangle ABF adding the area of triangle CDF is going to be equal to a half of the area of the square ABCD. Right? So it's going to be equal to 6, of course, because the area of ABCD is 12, right? So half of 12 is 6. All right, now, so in order to find the area of ABF, I need to subtract the area of triangle CDF from 6. Just simply rearranging the terms, of course. So now our next purpose is to find out the area of triangle CDF. So now we know that AE is equal to ED, where EF to FC is 2 to 1. So do you still remember what we have learned in the previous lesson? Like the equal height models, right? The equal height models. So first of all, we can try to find the area of triangle EDC, which includes the base EC, right? So the area of triangle EDC, how do we calculate it? We calculate it by ED times DC divided by 2. So what is ED? You can see that AE is equal to ED from the question. So it means that it is going to be half the side length of the square, right? So we can say that it is half the length. And what is DC? DC is the length. So this is ED, and this is DC. Do I know the length for a square with area 12? Not really. But it doesn't really matter. It doesn't really matter. Let's see how it's going to work out, okay? So, of course, I still need to divide it by 2. Don't forget about that dividing 2. So if I'm dividing half the length times length by 2, I'm going to get a quarter of the length times the length. Wait a second. What is the length times the length? It is exactly just the area of the square. So it means that the area of EDC, triangle EDC, is going to be equal to a quarter of the square. That is a quarter of 12, which equals to 3. All right. But we are not looking for the area of triangle EDC. We're looking for the area of triangle CDF. Now you can see that inside the triangle EDC, The triangle EFD and the triangle CDF has the base ratio 2:1, which means that they should have an area ratio of 2:1 as well. If you still remember what we have learned in the previous lesson. So the area of triangle CDF is going to be 1 part out of 3, which is a third of the whole area of triangle EDC. That is a third of 3, which is 1. So now we know that this is equal to 1, which means that the area of triangle ABF is equal to 6 take away 1, and that's equal to 5. So that's going to be the answer to this question, 5.